You're listening to People, Places, Planet, the official podcast of the Environmental Law Institute, a nonpartisan, nonprofit research and education institute making law work for people, places, and the planet. If you enjoy the podcast and want to support our work, consider donating at eli.org/donate.
Welcome back, listeners, to another episode of People, Places, Planet. I'm your host, Dara Albrecht, and I'm excited to bring you an episode about the sea level rise issue today. Sea level rise continues to accelerate, bringing with it new challenges for coastal communities. Some of these challenges include more frequent and extreme flooding, in addition to more intense damages from severe storms such as hurricanes. As communities and governments pursue adaptation options, new legal issues are emerging. If you're a regular listener of People, Places, Planet, you will know about the Environmental Law Institute's Climate Judiciary Project, or CJP. CJP is a first-of-its-kind effort that provides judges with authoritative, objective, and trusted education on climate science, the impacts of climate change, and the ways climate science is arising in the law. One of the ways that the Climate Judiciary Project achieves this is through its written curriculum, consisting of a series of modules on climate science and its interaction with the law. Recognizing the uncharted legal waters we find ourselves under, the Climate Judiciary Project recently published a curriculum module on sea level rise and the diverse set of constitutional, statutory, regulatory, and tort claims that plaintiffs have brought to court because of it. Today's episode is going to build on that work. I'm here with Jeffrey Peterson, who has 40 years of experience in environmental policy development and program management, particularly focused on water issues. He's currently a visiting fellow at ELI and co-chair of the Coastal Flood Resilience Project, a network of organizations working to strengthen U.S. coastal resilience. He's also the author of A New Coast: Strategies for Responding to Devastating Storms and Rising Seas. He also sits on NASA's Sea Level Rise Practitioner Advisory Board. Until 2017, he was a senior policy advisor in the EPA Office of Water responsible for climate change. In that capacity, he co-chaired the EPA Sea Level Rise Work Group and was a member of the federal Interagency Sea Level Rise Work Group. Jeffrey has also worked for the White House Council on Environmental Quality and for the Senate Committee on Environment and Public Works. We're going to talk about understanding sea level rise, discussing impacts, and looking at some policy and planning responses. Whether you're a policymaker, attorney, scientist, resident of a coastal community, or just an interested layperson, this podcast will be for you. So it's wonderful to have an expert like you with me here today, Jeff. Thank you for being here.
Well, thanks, Dara. It's great to be here, and I look forward to talking to you.
So, Jeff, you've had a distinguished career in environmental policy. Could you share what drew you to focus on coastal resilience?
Well, I worked at EPA on clean water and drinking water programs for many years. About 20 years ago, EPA was expanding efforts to evaluate climate change impacts on water quality and water supply. I got involved in that work, including developing climate adaptation plans for clean water and drinking water programs. As part of that, we documented the high risks that coastal water resources face from both rising sea levels and more severe storms and hurricanes. From the point of view of the water programs, the most obvious risks were to the huge investments that EPA had in building sewage treatment plants and drinking water plants in coastal areas. Many sewer plants are designed to discharge to coastal waters and were therefore located at low elevation right next to coastal waters. But the more we looked at the situation, the more impacts that we saw. In addition to water treatment plants, all sorts of major infrastructure along the coast is at risk of flooding. Transportation assets, power, energy, defense facilities, and of course, homes, businesses, and communities are facing increased flood risks, as well as ecosystems, wetlands, and beaches. Some of them will be inundated by rising seas unless they can migrate inland. So while the big picture climate impacts of heat and inland rainfall and drought are all important and somebody needs to deal with them, the coastal impacts have always seemed to me to be potentially the most damaging to human and natural systems and the most costly to adapt to. So given all that, I've been focusing my efforts on these coastal problems.
Thank you so much for explaining that a little bit, Jeff. I completely agree with this sort of encroaching threat that has the chance to impede on our way of life in many ways. So, moving forward to understanding sea level rise, what exactly is sea level rise and what are some primary factors driving it?
Well, when we speak of the challenge of sea level rise, we're really talking about a very gradual increase in the level of ocean water in relation to the land. While it may be gradual, it can really add up with as much as 4 feet of sea level rise projected in some places along the US coast within 75 years. Remember, we're not talking about tides being higher. There will always be tides, mostly as a result of the interaction of the Earth and the Moon. But high tides of the future will reach further inland as a result of higher elevation of ocean water. In terms of causes, and not getting too technical, there are three big ones. First is thermal expansion of the ocean. The release of greenhouse gases causes warmer air temperatures. The temperature of ocean waters increases, and these warmer waters expand and ocean levels rise with respect to the coast. The second big factor is the melting of land glaciers and polar ice sheets. And here again, warmer air causes melting of ice on land that runs off into the oceans and causes higher sea levels. And finally, land subsidence is a factor in some places. And so this occurs when human development or sometimes natural changes cause a gradual sinking of the land, which has the effect of making sea level rise with respect to the land. So those three factors, thermal expansion, melting of glaciers and polar ice sheets, and land subsidence, are the principal causes of rising sea level.
Thanks for expanding on that a little more. It's interesting to hear about all of these different impacts because I think that when some folks think about sea level rise, they think about the ocean as some big pool and that it's just rising at the same rate and that there's just one cause. But I am sure it's more complex than that. Are sea levels rising at the same rate everywhere?
Well, no, they're not. There is a thing called global mean sea level, which is the average height of the ocean surface. That used to be measured by tide gauges, but since 1993, it's been measured by satellites. The ocean is a pretty dynamic place, and the combination of major ocean currents, other factors such as variable land subsidence, means that on different coasts, sea level rises at different rates. In general, in the United States, the lowest rates of sea level rise are in the Northwest, and the highest are along the Gulf of Mexico coast.
So, what causes these regional differences? And are there any regions that are more vulnerable to changes in sea level rise?
So the causes of the regional variation, well, they're different in all the different places. And sometimes it's ocean dynamics, and sometimes it's subsidence, and often it's a mix of both. For example, Atlantic coastal currents in the ocean, pull water out to sea away from the U.S. Atlantic coast. But there is concern for these currents weakening as the climate warms. And that would have the effect of allowing all that ocean water to pile up along the Atlantic coast, raising sea levels, sometimes in some places as much as 2 to 3 feet.
How do scientists measure and project the sea level rise? And what kinds of data help us understand what's happening along our coasts?
Well, in the case of past changes to sea level, the traditional method is tide gauges. But like I said, since 1993, satellites have measured sea level rise from space. Projecting future changes requires making assumptions about lots of factors. For example, the first question you might ask is, well, how high by when? And most projections are to the year 2050 or 2100. There's more confidence in the 2050 projections with more variation in longer term projections. The second key assumption is how much future warming we'll be experiencing over the projection period. The amount of warming that actually occurs, whether it's a little or a lot, will push estimates up or down, especially for the 2100 and beyond period. One question will be, does the world meet the Paris Climate Accord goal of limiting warming to 2 degrees Celsius above pre-industrial levels? And a final question that affects the projection is where on the coast you're measuring. The coastal location will account for impacts of ocean current and land subsidence. So when you roll all that together, you decide what year you're projecting to and how much warming you think will occur over that period, where exactly on the coast you're trying to make the projection. Then you can apply the science and the models and generate an estimate of the amount of sea level rise that you are likely to have.
Interesting. And how does that translate to what is projected in the future?
I mentioned 4 feet by 2100 at one point. But I think it's important to really convey to people the idea that we're really talking about a need to move to higher ground. They may have heard millimeters and few inches. Everybody's going, oh, why are we moving? And so I think what really brings that more kind of into, oh, okay, now I get it, proposition is recognizing how the accelerating past sea level rise is really going to drive much more significant sea level rise in the future. In 2022, federal agencies led by NOAA published a report including sea level rise projections, not just globally, but for the US coast and for many specific locations along the coast. This report is really the gold standard for understanding future sea level rise in the United States. And what it says, by 2050, 25 years from now, US sea level rise is expected to be between 1 and 2 feet, depending on where you look along the coast. In general, the NOAA report indicates that sea level could rise by between 2 and 4 feet at different places along the coast by 2100. In other words, 75 years from now. And this report projects future sea level rise all the way out to 2150, with an intermediate scenario estimate of average US sea level rise of 7 feet and a high estimate of over 12 feet. In the western Gulf of Mexico, the high scenario is almost 15 feet by 2150. So there are several points that I think are important to make here. First is that sea level rise is generally higher along the US coast than the rise that will occur globally, roughly a foot higher. And under an intermediate scenario, up to 4 feet on average along the US coast by 2100. Rather than, say, 3 feet by 2100 globally. The rate of sea level rise has been accelerating for the past several decades, and sea level rise projections are based on models for which there's a consensus. When I say consensus, what the scientists are looking for is high or medium confidence in the science supporting the projections. But there is research in the area of ice sheet instability that's considered low confidence, in other words, a low likelihood, but it can't be ruled out. And if we end up finding that ice sheet instability is a real concern, our projections of future sea level rise, well, they're going to increase significantly and rapidly. In very general terms, maybe by 20% greater by 2100, with greater increases in later years. And perhaps the most important point, sea level rise does not stop by 2100 or even 2150 just because the projections stop. Under most climate scenarios, sea level will keep rising for centuries. The rate of long-term future sea level rise is related to the rate the planet warms. In other words, if we were to achieve the 2-degree warming cap of the Paris Climate Accords, we would see perhaps slower rate of warming, but that wouldn't stop sea level rise. And if we don't achieve the climate accords and the world gets even warmer than 2 degrees increase above pre-industrial levels, the rate of sea level rise will be faster. And that's a matter still of some debate.
I can imagine how our projections could slightly change when we consider whether a country is committed to the Paris Climate Accords or what kind of weather events a certain region has experienced. But right now, there's a steady high rate and acceleration of global sea level rise. So, what is driving that?
So the short answer is a warming planet is driving first melting of the ice on land, the glaciers and ice sheets, and second, causing the thermal expansion of the ocean. But there are other factors like the changes in ocean currents and land subsidence. In January of this year, the World Meteorological Organization confirmed that 2024 was the warmest year on record. The past 10 years have all been in the top 10, and this is a pretty extraordinary streak of record-breaking temperatures. We've likely seen the first calendar year now with global mean temperatures of more than 1.5 degrees Celsius above the pre-industrial average.
That is just a shocking number, hearing about that and the last 10 years that we've lived being some of the hottest years on record. So, what do these trends tell us about what's to come?
So from 1993 until the end of 2023, global mean sea level has risen by a bit over 4 inches. That doesn't sound like much, but the increase was 2.1 millimeters per year in 1993. But that has more than doubled to 4.5 millimeters per year in 2023. So over 30 years, we're seeing the rate of increase go up by more than double.
And one quick sidebar, Jeff. So I feel like sometimes I hear the counter argument that a millimeter is so small. So you're saying things are going up by 1, 2, 4 millimeters. How much of an impact can 1 millimeter of sea rise really have on a community or a coast?
Well, the impacts are going to vary depending on the topography of each individual community. Low-lying flat communities are obviously more at risk from a given increment of sea level rise than communities that are at higher elevations or protected by cliffs or protection structures. But even a little bit of sea level rise can do a lot of damage, especially because when we have storms come through, the storm surges of water cause serious flood damage. And as sea level rises, just a little bit of sea level rise can make a storm surge reach further inland than it would reach if we were not experiencing sea level rise.
So that leads me straight into my next question. What kinds of physical and ecological changes are we already seeing along the coast due to sea level rise? You spoke a little bit about how rising sea levels impact coastal communities, so I want to give you a chance to expand on anything.
Well, there are three major types of impacts from sea level rise. The first is flooding of communities. That's homes and businesses, streets, city buildings. But keep in mind that this is permanent inundation, not just the temporary flooding that we see during a storm surge. The second big type of impact is the loss of ecosystems. The best examples being wetlands and beaches becoming open water unless the ecosystem can migrate inland. And the third major type of impact is the loss of infrastructure assets, roads, bridges, power plants, water treatment systems. As water rises, these plants have difficulty continuing to operate or are stranded by water surrounding them. In the case of coastal communities, parts or all of hundreds of U.S. communities will be inundated by rising seas. These communities are home to millions of people. Some of these communities will also have to deal with flooding from hurricanes, and hurricanes can drive storm surges 15 feet, and rising sea level will push them further inland. And impacts do not stop at the loss of property. Communities rely on property taxes to fund local government, and as homes are lost, so too will significant tax revenue. There's also a risk of loss of community social cohesion and integrity. There are also psychological impacts from the loss of a home and community. And finally, it's important to remember that many coastal communities include low-income and minority populations that have limited resources to adapt to rising seas. They may have the same vulnerability as wealthy neighbors, but experience much greater impacts because they're less able to adapt.
Hearing about this waterfall of potential damages really puts into perspective that it's not just, a millimeter or two. It's the potential destruction of a city's revenue, a way of life, and maybe even a city's psychological well-being. Are these kinds of changes already being seen in communities around the world?
So the global impacts of sea level rise will be pretty devastating. There are many big cities and lots of smaller communities that will be significantly affected by rising sea levels around the world. In the United States, along the Atlantic coast, some of our major cities, New York, Boston, but also other communities like Charleston, Miami, of course, New Orleans, all face sea level rise challenges and are working to identify the best adaptation responses.
Thanks for expanding on that. Going back to the changes and damages, can they be attributed to human activity? And if so, how?
So the short answer is yes. It's pretty well established that burning fossil fuels releases greenhouse gases that cause the planet to warm. Warmer air and water temperatures cause thermal expansion of the ocean and melting of the ice sheets. And the changes in ocean currents are also due to temperature changes. Even land subsidence is partly due to human development and withdrawal of water from the land. So the consequences of human activities are pretty clearly a major factor in the sea level rise that we're seeing.
Now let's move to policy and planning responses. What legal frameworks or doctrines come into play when governments respond to sea level rise?
When governments decide that they want to reduce their vulnerability to rising sea levels, they commonly work with three general types of tools. First is land use controls. So local and state governments use plans and regulations, and they can play an important role in limiting new development, particularly in places at risk of rising sea levels, and thus avoiding future property losses. A second type of tool is insurance programs. The federal and state governments manage the National Flood Insurance Program that provides homeowners a financial backstop in the event of property loss due to flooding. But the National Flood Insurance Program also provides that local communities adopt local ordinances that help reduce flood risks in that community. And finally, financial tools. State and federal governments can use disaster planning funds to help adapt to rising sea levels and disaster relief funds to pay the cost of recovery from a major storm. Another financial tool is to buy out properties that are at risk of loss due to rising seas.
So, what do adaptation and mitigation mean in this context?
Well, mitigation is a term often used to describe strategies to reduce greenhouse gas releases. For example, use less fossil fuel. So the success of mitigation is pretty important to slow the rate of warming and thus the rate of sea level rise. Adaptation is a question of what to do about sea level rise that you are faced with. What strategies, programs, or policies would result in less loss of property, less harm to ecosystems, and fewer impacts on major infrastructure assets.
Thanks for explaining that specific context. What are some of the strategies being used or considered to respond to sea level rise?
People commonly talk about three key strategies. First, protection. The idea is, well, you could use physical infrastructure, a seawall or a bulkhead to hold back rising waters. The second strategy is accommodate. Usually that means strategies like elevating buildings to avoid high water, or maybe elevating some key equipment like electrical panels to avoid the impacts of rising waters. And the third key strategy is relocation. The basic idea is to move to higher ground, either on the same piece of property or maybe in the same community, or also maybe someplace totally different, but to have a vertical distance of safety from rising waters.
I know there are also a number of infrastructure solutions on the table. Can you talk about some of these possible solutions? I've heard propositions like nature based solutions or hard armoring and more.
Well, most people think of infrastructure solutions as the obvious first choice. They can just put up a wall and protect their home or community. But there are some big problems with this approach. First, it is a temporary solution. It may work even for a few decades, but sea level rise is not going to stop, and you'll need another plan before long. Infrastructure is expensive, and it will be used to protect high value assets, but that might leave lower income people in places with little or no protection. So there are some equity issues involved in how do you spend the money you have to build infrastructure and what do you protect. And third kind of consideration is that hard infrastructure is often damaging to coastal ecosystems, such as wetlands and beaches. And so it's degrading the coastal environment in order to preserve property that was built in risky places. One alternative to that hard infrastructure is the use of nature-based solutions, or sometimes in the coastal context, we talk about living shorelines. These projects can reduce ecosystem impacts while providing some temporary protection from rising seas. But most natural infrastructure measures are really buying time and are not likely to survive as higher levels of sea level rise occur.
Thanks for going more into detail about those possible solutions, Jeff. I liked what you talked about in terms of looking at the community's vulnerability and folks in a community who might already be vulnerable and making sure we're not leaving them out of the protective measures we're putting into place. So, how do these land use decisions, zoning regulations, and solutions shape a community's vulnerability or resilience?
Well, they mostly influence where new development occurs, and they play a key role in discouraging new development in places that are most at risk of flooding by rising seas. They might also direct development away from places where ecosystems will need to migrate as sea level rises. And they might influence how new development is designed. For example, they might require elevation above the flood level to reduce future damage from rising seas.
Interesting. And one more question before we move on to talking about emerging litigation and judicial considerations. I've heard of the phrase managed retreat a lot in regards to sea level rise, but what is it? What does it look like in practice? And what makes this idea so legally and socially complex?
Well, this is a big topic, and it is critical to the success of our efforts to adapt to rising seas. First, what we are really talking about is recognizing that property, ecosystems, and infrastructure right along most of the US coast will all need to move to higher ground at some point. It might make sense to buy some time with a seawall or a nature-based solution or elevating individual structures. But moving is really the final act. So it is really a question of when to move, not whether to move. Lots of people look at the increasing coastal flooding and just decide all on their own to move to a safer place without any engagement from the government. This is relocation of people, if not property, but not really managed in the sense of managed retreat. But as sea level rise accelerates, more and more communities are going to be dealing with water in the streets. Right now, some governments have been offering voluntary buyouts to people who are ready to move. There are other people that want to run the risk and just stay put. Buyouts can reduce risk and can be especially helpful for assisting low-income people, but they are expensive, and as the number of people wanting buyouts increases, it might exceed the number of buyouts that governments can pay for. The idea of managed retreat of a whole community that is funded by the government has been tried in a few small communities, such as tribal villages and some neighborhoods. Managing the retreat of larger communities, including with buyouts, would be extremely expensive and require federal funding, supported by a political consensus that paying people to get them out of harm's way on a massive scale is a good use of taxpayer dollar. What seems more likely is that some people will leave before home values start sliding downward. Other people will stay till it's too late and take a big financial loss when they sell their homes. And a few people will get buyouts through disaster assistance or through programs focusing on people with the greatest financial need. Many people will likely just miss the moment holding a house that no one will buy and that ultimately they're unable to live in because it's being flooded.
Thank you for expanding those. And I think that learning more about these adaptation and mitigation measures, it really puts into perspective how drastic this issue is. It has the chance to affect entire communities, financial systems, and ways of life. And as such, I'm sure not everyone agrees on what the best course of action for managing the sea level rise issue is. And so some of these adaptation responses are resulting in legal disputes. Could you talk about those and what the role of the courts will be as we weigh different adaptation options? What kinds of sea level rise related disputes are appearing in courtrooms across the country?
Well, sea level rise adaptation will be generating a lot of litigation, and the litigation could fall into any number of different categories. There will be disputes related to the administration of land use and zoning laws. There will be debates about risk disclosure and how the government is imposing disclosure risks. And there'll be debates about damages and compensation. For example, there's litigation by states and local governments charging big oil companies with causing climate damages, including sea level rise, and seeking compensation for those damages with the idea that the compensation would be used to adapt to climate impacts, including sea level rise. But having all of that on the table, probably the single biggest area of litigation is likely to involve cases related to takings of property and whether the government's right to take property by eminent domain when it provides just compensation is being fairly exercised. Under the Fifth Amendment, governments can take property for a public purpose, but must pay just compensation. And owners can refuse to sell and can argue in court that a taking is not justified. There are evolving court cases about when a taking related to sea level rise is really justified. And without going into all the details, just one consideration is whether the owner of the property had an investment-backed expectation to own or build in a risky place. In other words, if a city issued a building permit for a lot, the homeowner had an investment-backed expectation to build there. One way for local governments to respond to litigation over a proposed eminent domain or takings action is to have a general policy of being clearer about warning people where to build, where it's not safe to build. And that involves better risk communication. Another form of takings cases is litigation against a government for not maintaining public services, like a road washed out by rising seas. A homeowner might argue that the city should be required to maintain a road or a home regardless of rising seas. But there'll also be litigation related to land use and zoning that does not involve a taking. In the context of managed relocation, a key legal issue will be whether government actions, short of outright eminent domain, such as condemnation of unsafe structures due to rising seas and flooding, will be considered a taking under the Fifth Amendment.
Thank you for that explainer of what kinds of disputes could be appearing in courtrooms across the country. It's clear that this issue will involve private citizens, private companies, and governments that all must work together to resolve this issue. So, looking ahead, what are the biggest scientific uncertainties that could shape how we plan for sea level rise?
Well, the single biggest uncertainty about sea level rise is not how much it will rise. It's going to rise a lot, but how fast it will rise. That rate is linked to how fast the planet warms. That's not really a science question, but a global political question that sea level rise scientists just have to account for in their work. In terms of science questions related to sea level rise, let me mention just three. First of all, will sea level rise stop? There is a general consensus that limiting warming to 2 degrees Celsius per the Paris Accord will slow the long-term future rate of warming, but that sea level rise will be continuing even if the warming is capped at 2 degrees. Understanding that sea level rise is unstoppable helps inform the policy debate about how to adapt to it and puts the importance of moving to higher ground in a clearer context. The second science question is related to ice sheet instability. The international and US estimates of future sea level rise are based on models that generally assume the stability of Antarctic ice sheets. Some research, however, indicates that Antarctic ice sheets may be more unstable than thought, with special concern for the collapse of the Thwaites Glacier, the so-called Doomsday Glacier. Projection studies consider a major sudden loss of ice sheet stability to be unlikely. They term it a low likelihood, high impact ice sheet process that cannot be ruled out. But the studies have nevertheless identified how sea level rise would increase if these ice sheets prove to be unstable. So one question is whether the low confidence in the instability of ice sheets can be researched to be better understood and to have medium or high confidence that would allow development of projections that include that ice sheet uncertainty in the more direct estimates of sea level rise. That would be an important improvement in the projections that are used to plan for future sea level rises along the coast. A third scientific uncertainty is the future of the Atlantic meridional overturning circulation, sometimes called the AMOC. Some recent research points to a weakening or collapse of this current by 2050, while the more established view is possible weakening of the current, but not until 2100 or later. Given that the collapse of the AMOC current alone would raise sea levels by 2 to 3 feet along the U.S. Atlantic coast, this is a pretty important question.
So, thank you, Jeff, for expanding on these scientific uncertainties. It's interesting, and I'm sure our listeners will appreciate keeping watch on some of these factors in the future. Before we finish, are there any final thoughts or insights you'd like to share about sea level rise?
Well, one thing we did not cover, and it's worth remembering, even with the risks of sea level rise and storms, many people keep moving to live right along the coast in risky places. The population right along the coast is expected to double by 2060. That's going to make managing the process of moving back from these risky places much harder in the future than it is today. But finally, it's important to remember that sea level rise will be a game changer for the U.S. coast, and we are not doing enough to prepare for the coming losses of homes and communities and ecosystems and infrastructure. Local and state governments are having some success in preparing for rising seas, but most have not come to grips with the reality that communities, infrastructure, ecosystems will need to move inland to higher ground. The federal government could play a leadership role in helping communities cope with rising sea levels, but so far that hasn't really happened. And to be successful in doing our very best to adapt to rising seas, we really do need for the federal government to step up and provide some leadership to help states and homeowners, local governments, and others deal with this pressing challenge.
Thank you for those closing thoughts, Jeff. I think it's sage advice to realize the urgency of the moment and to understand that sea level rise can have a real impact on our lives and communities in the coming years. I really appreciate you coming on the podcast today, and it's been wonderful to hear about your experience and your expertise in the sea level rise issue. For our listeners who would like to learn more, as I mentioned at the beginning, the Climate Judiciary Project at ELI has just released a module about sea level rise and the multiple legal issues that could arise relating to it. So check that out at cjp.eli.org. Thanks again for joining, Jeff.
Thank you, Dara. It's been a pleasure.
Thanks for listening to People, Places, Planet, the official podcast of the Environmental Law Institute. Our work wouldn't be possible without the support of people like you. If you'd like to learn more about what we do, attend one of our events, or support our work financially, head to eli.org.